Now for solving algebraic equations, I'm going to suggest you keep a few things in mind whenever you approach an algebraic equation. I'll refer to basically these four ideas here, and I want to just get the point across. These are not fixed rules that you always have to follow. Okay, these are suggestions. They always work. Eventually you're going to learn a lot of tricks that work as well, but to get good at solving algebraic equations, you really should try going down the same path repeatedly until you get very accustomed to it. My first goal is going to be to get x by itself, or that's basically what I always ask when I approach the problem. If you can get x by itself, you have the answer. And when I say by itself, I mean, flip this over a little. By itself. If you have x equals, I don't care what's over here, you've solved the equation. Okay? If you have a whole bunch of stuff equals x, I don't care what's over here, you've solved the equation if you have x by itself. So this could be something nice and neat like a 5, or it could be negative 3k over q to the 7th power. It doesn't matter. These are both solved algebraic equations. Okay. The second thing is you decide what you want to get rid of. So that's what do I want to get rid of. And in this case, let's move that. We're going to address number 61, and I'll basically walk you through using these rules. Okay. And let's zoom in a little on this. Okay. I think I'll zoom out a little. Sorry for the indecision here. Alright, so I want to get x by itself, and usually I start out deciding what I want to get rid of, but in this case I have two like terms on one side of the equal sign, so I can just put them together. Alright, so usually in math we say let's clean it up. Alright, so the signs are the same, we'll add and keep the sign, so that's going to give us 29. Okay, and we'll just bring down everything we haven't touched. The equal sign, okay, so we haven't really started using this yet. We just cleaned up one side of the equation. Alright, I just combined two like terms. Now I'm back to referring to this procedure. I still want to get x by itself, which means I want to get rid of that positive 12. Okay, so what do I want to get rid of? Positive 12. How is it held there? It's held there by addition or subtraction, which is to say it's not multiplication, it's not division. So I can use the opposite operation. Alright, with addition or subtraction you achieve the opposite operation by just putting the same number with the opposite sign. So I'm not taking this positive 12 and making it negative. I'm introducing something new to this side of the equation. I put a negative 12 here. And to solve algebraic equations, whatever you do on one side, you have to go to the other side of the equal sign and do the exact same thing. Alright, so I put a negative 12 on each side of the equation. As long as I put the same thing on each side, I can do just about whatever I want. Okay, and then I just draw a line here and bring everything down. Positive 12, negative 12, that's a 0, but I don't have to write it because I already have an x right here. So I can't leave air on one side of the equation, but I have an x there. So that's good enough. Here the signs are different. Subtract, keep the sign of the larger. So we figured out that x is equal to 17. And let's solve another one. We'll go down here to 63. By the way, whenever I suggest rules, I think I'll cover some more of this up. There we go. Whenever I suggest these sorts of rules, you might want your rules to be a little bit more detailed, okay? But this is my idea of the most basic way to write it. Okay, so I want to get x by itself, but right off I see that I have like terms on one side of the equal sign, so I can put them together, okay? So let's say here the signs are the same, so I'm going to add and keep the sign. So that'll give us negative 11x, okay? And then I'll bring down whatever I haven't touched. The equal sign, very important, and the 11, okay? And now I'm still trying to get x by itself. What do I want to get rid of? I want to get rid of that negative 11. How is it held there? Well, it's held there by multiplication. And this is where you have to be reading that math shorthand. A number next to a variable means to multiply. The opposite operation is division. The opposite of multiplication is division. So by math shorthand, if you put a bar there with something underneath, this is negative 11x divided by negative 11. Okay? So to keep my equation balanced, I have to introduce a negative 11 to the other side as well. All right? And I want you to see, I did not take this negative 11 and push it down. I introduced a negative 11 to one side, so I have to introduce a negative 11 to the other side. Okay? And now this cleans up. Negative 11 divided by negative 11 is a positive 1. So I have x all by itself. That's my goal. How do I get x by itself? Equals negative 11. Sorry, this is a positive 11. 11 divided by negative 11 is negative 1. So that's our answer. X equals negative 1. Let's take another look here. Perhaps number 65, just because the way it's written looks a little bit strange to me. There's a couple things going on here. You have like terms, we could put them together. These like terms, we could put them together. So that's usually what we prefer to do. I could start by getting rid of that negative 4, which is held there by division, but it gets rather complicated. Your life will be easier if you just clean up each side whenever you can. Okay? So remember, there's a 1 in front of the x. Okay, the coefficient is 1. You're not required to write it. So negative 4x, positive 1x, we put them together, we get negative 3x. All right, all we did was combine our like terms. Over here, I don't like two signs in front of a number, so I use my rules for multiplication. That's a positive. The rules for multiplication are if you have positive times a negative, you get a negative. Just to try to really show what I'm doing here, I'll put in another step. Okay, all I've done so far is clean up what's up there. All right, I can clean this up more. I can put these two together. Signs are different. Subtract, keep the sign of the larger. So I'll keep my original one in there. So what happens here if we've got, I got to slide this over, 72 and 18. 54. Okay. So when I combine these two, I get 54. Bring down my equal sign. And negative 3x. Sorry, that's not really looking exactly like a 4. So let's see if we can clean it up a little. There we go. Alright, I still want to get x by itself. So all I really need to do is get rid of this negative 3, and I will have x by itself. Okay? That negative 3 is held there by multiplication. How is it held there? It's held there by multiplication. I'll use the opposite operation, division. And by math shorthand, if I put a bar there with something underneath, this means divide. Okay? So in order to keep it balanced, if I put a negative 3 on one side, I have to put a negative 3 on the other. And now this will clean up. Negative 3 divided by negative 3 is a positive 1. So I just have x by itself. If you want to put a 1 in front of it, you're welcome to, but you're not required. And then 54 divided by a negative 3 is going to be negative, and I believe that's 18. Okay, so this one solved yields x is negative 18. Let's see if we can take a look at filing number 69 here. Okay, there's a few things we're going to be able to combine. Alright, so we're going to clean up each side of the equation before we really get started. Okay, I want to get x by itself, but my life's going to be easier if I clean things up first. Okay, so this 3x and this 4x, I can combine those, and that will give us 7x. The 16 is plus 16 or positive 16, however you want to say it. It's just going to drop down. Over here, I can combine the negative 20 and the negative 36, and that will give me negative 56. Okay, and so all I did was clean up a little, and now I'm just going to bring down whatever I haven't touched. So this positive 16 has to come down, the equal sign comes down, and this negative x comes down. Alright, and I'm still trying to get x by itself. Now I've got a little bit of a problem. I have an x on this side and I have an x on this side. So I either need to get rid of this one or I need to get rid of this one. And by the way, at this point, I have 4 options. I have at least 4 options. There's actually more. I could get rid of the 7x. I could get rid of the 16. I could get rid of the negative 56, or I could get rid of the negative x. I am most concerned about the variables, so that's what I tend to address first. I'm going to get rid of this negative x, so I'm going to, how is it held there? Okay, so again, back to these. What do I want to get rid of? I want to get rid of that negative x. How is it held there? It's held there by addition or subtraction. So I'm going to use the opposite operation. Okay? If this is a negative x, I'll put a positive x underneath it. And again, I didn't take this negative x and push it down. I introduced a positive x. If I put something on one side of the equation, I have to put it on the other side of the equation to keep it balanced. And now I just draw a line and bring everything down to see what I still have to deal with here. So that's a positive 1x, so now we have 8x, positive 16, and just a negative 56. Negative x, positive x, I don't know what x is, but if I have a negative and a positive when I put them together, I got nothing. So I don't have to write that 0. Okay, now we're a little closer, but we refer back to this again. How do I get x by itself? I need to get rid of the 8, and I need to get rid of the 16. In general, your best bet is to get rid of things that are added or subtracted, at least at this point in mathematics. So to get rid of that 16, I want to get rid of the positive 16. How is it held there? Addition or subtraction. I'll use the opposite operation. So if I put negative 16 here, That means to keep it balanced, I also have to put a negative 16 here. And then I'm just going to draw a line and bring everything down and see what I'm left with. 8x drops down. These two become 0, so I don't need to write anything. And the signs are the same. I add and keep the sign. It's going to be negative 72. I'm one step away from the answer now. I want to get rid of the 8. So again, I refer back to this. How do I get x by itself? What do I want to get rid of? I want to get rid of the 8. How is it held there? By multiplication. That's math shorthand. If you have a number next to a variable, you're supposed to multiply. Then I use the opposite operation, which is division. And again, math shorthand. If I put the bar with the 8, that means divided by 8. To keep it balanced, I do the same thing on each side. And, whoops, lo and behold, 8 goes into 8 once. X equals, and negative 72 divided by 8 is negative 9. Okay, so that's our solution. And I want to mention, I'm going to have to zoom out for a second. Whenever you get an answer to an algebraic equation, you can plug it back in to your original equation, or for that matter anywhere along the line, but to be safe, you plug it back into your original equation and you'll get a true statement. Okay? So if I put a negative 9 right where that x is, where that x is, where that x is, combine all my numbers, I will get a true statement. Maybe I'm just going to leave it there.